Hello students, in today's session of NCERT chapter Mechanical Properties of Liquids, further very basics on the topic of viscosity will be cleared through illustrations. In earlier session, we have gone through very basics 1, that is pressure, very basic 2, Archimedes principle of flotation, very basic 3, Bernoulli's theorem, which you can review all these on sethiswiftlearn. In today's session, we are going to discuss Newton's law of viscosity, viscous force or viscosity, Stokes formula, terminal velocity, Ohms law in physics, Ohms law in fluids, and Reynolds number, how to identify turbulent flow, how to identify laminar flow, and other number of topics will be cleared through this session. It is requested to go through the session completely. Now start with the concept and question. Before start of the questions, let's discuss certain concept regarding viscosity. What is viscosity? In solids, when body slides over another solid body, the force of friction opposes the relative motion of the solid body. Similarly, in liquids, when layer fluid slides one over another layer of same fluid, a force of friction comes into play, which is called viscous force. This force opposes the relative motion of the different layers of the fluid. The tendency of fluids to oppose the relative motion of its layer is called viscosity of fluid. The backward dragging force called viscous drag or viscous force. Cause of viscosity. Velocity of layers of different liquid increases uniformly from bottom to the top layer. For any layer of the liquid, it is in lower layer pulls it backward, while it upper layer pulls it in forward direction. What is fluid force? Fluid friction force or force of viscosity? That is directly proportional to area of the surface area of surface, and directly proportional to that is velocity gradient. If you combine these, and then constant proportionality is known as coefficient of viscosity. This is the lower layer, this is the upper layer. This is the upper layer, right? This is the area of upper surface. This is air, right? And the difference in velocity with respect to this distance, dv by dz, is known as a velocity gradient. And coefficient of viscosity, its unit is SI unit, CGS unit. SI unit is decapoise and poise. 1 decapoise equal to 10 poise. What will be dimension निकालनी है viscosity की, then eta will be equal to mLT minus 2 upon A2 L2 upon dV by dz. dV by dz means LT minus 1 upon dz, that is L. On simplification, this cell goes, this cell goes, comes out to be M L minus 1 T minus 1. This is the dimension of coefficient of viscosity. Right? Further For the effect of temperature on viscosity, coefficient of viscosity is inversely proportional to root T and coefficient is proportional to root T. This is for liquids, this is for gases. Relative velocity of viscosity क्या आता है? Coefficient of viscosity of liquid divided by the coefficient of viscosity of water. Coefficient of viscosity of water at 10 degree centigrade temperature is 1.3 × 10⁻³ Newton second per meter square. ठीक है. Relative viscosity of blood remains constant between 0 degree centigrade to 37 degree centigrade. Important point. What is critical velocity? The critical velocity of liquid is the limiting value of its velocity of flow up to which the flow is streamlined, above which it becomes turbulent. Phase K is dimensionless, constant, coefficient of viscosity, density of liquid, radius of pipe. This is the critical velocity. Reynolds number. Reynolds number is given by rho Vd divided by eta. Density of liquid, velocity of liquid, diameter of pipe. This is also the inertial force divided by force of viscosity. Based on the Reynolds number 2000, 3000, laminar flow, turbulent flow. Laminar flow, in between it may be laminar or it may be changing nature. We can definitely say below this number is laminar, above this number is turbulent. In between is the mixture of that. Right? Further. What is Stokes? Backward dragging force acting on a small spherical body of radius r, moving through a fluid of coefficient viscosity V and velocity is given by F equal to 6 pi eta RV. 6 pi eta RV. That is, this is the weight of the body. This is the viscous drag F equal to 6 pi eta RV, which is velocity dependent, which is not constant. This is upthrust. That is upthrust. Right? Now, 6 pi eta coefficient viscous radius by velocity. Application Stokes Law. Important application. Using the derivation of electronic charge with the help of Milton's experiment. Accounts the formation of clouds. Why the speed of raindrops is less than that of the body filling free with a constant velocity for height of clouds. This will help man coming down with the help of parachute. These are the applications of Stokes Formula. Next further. Terminal velocity. The maximum constant velocity required by the body while falling through a viscous force is called the terminal velocity. Vt is given by 2 by 9 rho b minus rho l g over eta r square. This has been derived by using when W equal to Ft plus Fv. When this will attain the maximum velocity, then this comes equilibrium will be, and this will be equal to this plus this. That is, weight of the body will be equal to upthrust plus viscous drag. In that case, we calculate it, we get this formula, right? Terminal velocity. Poiseuille's formula. The volume of liquid flowing out per second through a horizontal capillary tube length radius r under pressure difference is applied across and is given by this one. Pi p r4 over a theta L. Another force is applied pressure of fluid pressure. This is known as Ohm's law. Ohm's law in fluids. Fluid resistance क्या होगा? Fluid resistance will be 8 eta L upon pi r4. 8 eta in series. In series, what will be same? Current remains same. So rate of flow will be same. rate of flow of liquid will be same, and P will be equal to P1 plus P2. In parallel, V will go to V1 plus V2, right? Now, RS, R1 plus R2, like this, 1 over Rp equal to 1 over R1 plus 1 over R2 plus like this. This is all regarding Poiseuille's formula, right? Now, let's start with the question. Question is, plate of area 2 meter square is made to move horizontally with a speed of 2 meter per second. By applying horizontal tangential force over the free surface of liquid, if the depth of the liquid is 1 meter in contact with the bed is stationary. Coefficient viscosity of the liquid is 0.01 poise. Find the tangential force needed to move the plate. Concept applicable and solution. According to Newton's law of viscous force, eta A dV by dx dy dz जो मर्जी ले लीजिए depending on that. This is the coefficient of viscosity. This is the area of free surface. This is the velocity gradient. Velocity gradient. Right? According to question given now, the coefficient of viscosity is given 0.01 poise. This CGS unit. Area is given 2 meters square. If we know the velocity gradient dV by dx, our purpose is solved. This is known, this is known. Before substituting the value, we have to match the units. Either we have to follow CGS unit or we have to follow SI unit. Now, this is a bed which is stationary. This is depth 1 meter. Upper level is velocity V. This tangential force we want to find it out. So velocity gradient from this will be, this is V equal to 0. This is the reference line. So dV dx will be equal to 2 minus 0 upon 1 minus 0, that is 2 per second. Right? Therefore, F will be equal to eta 0.01 into 10 to the power minus 1. 1 डेका poise equal to 10 poise. तो इसको कन्वर्ट किया तो उसको 10 से डिवाइड कर दिया, ठीक है. Then A 2 on simplification this comes out to be 4 into 10 to the power minus 3 Newton. This is the answer, right? Next question. Before start of the next question, I will request that these concept killing videos, which are very, very useful for 11th standard, 12th standard, CBSE board, state boards, JEE, NEET, CUET, and other entrance examinations, which you can review on sethiswiftlearn. इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, please subscribe it and share with your colleagues and friends. Now let's start with the question. Question is, 8 identical small drops of water are falling vertical through a medium, each with terminal velocity v. If they combine to form a single drop, that terminal velocity will be. 4 options are given to, one of the options is correct. What is the formula for terminal velocity? 2 by 9 r square rho b minus rho l g upon eta. This is the formula for terminal velocity. How it is derived? Weight of thrust plus viscous drag, Stokes. F equal to 6 pi eta RV, right? Using this concept, this equal to this plus this. Now, according to question, I will write first general formula. If n drops of radius r combines to form big drop, then n into volume of small drop equal to volume of big drop. That is n into 4 by 3 pi r cube equal to 4 by 3 pi r cube. R comes out to be n to the power 1 by 3 small r. That is the radius of big drop. Now, V big from big upon V small will be equal to R big R square upon R square. This equation 1 from equation 1. Remaining as system is same. That is rho B, rho L, these are same. Therefore, here n equal to 8, n equal to 8. So, big R will be equal to 8 to the power 1 by 3 into small r. That is 2 to the power 2r. So, V big will be equal to R square, 2r square upon R square into V small. That is given to you. That is 4r square upon r square into V. That is 4V. This is the answer. Big drop की terminal velocity जो होगी 4V होगी. That is the B is the correct option. B is the correct option. Right? Next question. Question is, a solid sphere of volume V experiences viscous drag force F when descending with speed V in a liquid. If another solid sphere of volume 27V descend with the same speed V in the same liquid, it experiences viscous force. 4 options are given to you. One of the option is correct. Concept applicable and solution. We know, according to Stokes formula, six pi eta RV. Viscous force 6 pi eta RV. Right? According to question, V and it is same. Therefore, F proportional to R. Using this equation, then 4 by 3 pi r cube equal to 27, 4 by 3 pi r cube. Then R comes out to be 3R. R comes out to be 3R. Therefore, F1 over F2, F1 over F2 equal to R upon capital R. That comes out to be F upon F2. जब हमने find out करना equal to R upon 3R. This R goes. F2 comes out to be 3F. Right? Let's see the options available. Option D. Option D is correct option. Option D is correct. Option D is correct. Right? Next question. Question is, which of the following diagrams correctly show the relation between the terminal velocity of a spherical body in a liquid and viscosity of the liquid? 4 options are given to you. One of the options is correct. Concept applicable and solution. Critical velocity. Terminal velocity Vt is given by 2 by 9 r square rho v minus rho l g upon eta for a given setup for the same body. For given system, Vt or given system body, Vt is inversely proportional to 1 over eta. We know the graphical nature. Y proportional to x. Y is inversely proportional to x. Y proportional to x square. X proportional to y square, like this. Straight line passing through origin, rectangular hyperbola. That's hyperbola. In this case is applicable. In this case, this is rectangular hyperbola. This is rectangular hyperbola. Option C is correct. Option C is correct. Right. Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.